Hello guys, in this video I would like to explain that how we can perform correlation analysis in R and RStudio. In the previous video we have done about correlation analysis. There are two videos. One is about linear correlation analysis and the other was about rank correlation analysis using Spearman-Rho correlation and Kendall-Tau correlation analysis. And in the first video, in the linear correlation analysis in Python, by the way, those two videos are in Python. In the first video, in which we discuss about linear correlation analysis, I have explained about correlation analysis, different situation about correlation analysis, and about different assumption about correlation analysis, etc. In the second video, I explained the differences between the linear correlation analysis and the rank correlation analysis. For rank correlation analysis, we use two types of techniques like Spearman-Rho correlation analysis and Kendall-Tau correlation analysis. So if you want to know about these concepts, you need to watch those videos. The link to those videos is given in the description of this video. So I will now discuss about those things that's already discussed. So you can watch and you can know about those things. And if you want to know about the formulas, the theory, you can please Google. And I will have a video, but not now. In today's video, I will discuss about linear correlation analysis from online data, which is built-in data in R. So you will see how we can deal with the built-in data and how we can extract variables and how we can do correlation analysis for particular variable from their data sets. Okay, so these three are some cases which I already discussed, in the previous videos, which I have done in Python, and today I'm doing in R and RStudio. Particularly, we will do this in RStudio, and of course you can do the same thing in R. So, like when you have data like this, something like this means that there is a positive correlation, and if the data is like this in this direction, it's a negative correlation. And if you see the data like this, there is no trend, no pattern. So this means that there is very low correlation or there is no correlation. So let's move to RStudio, that how you can do this type of correlation analysis in RStudio. Okay. Okay, now let's load the dataset, that is mcors dataset. So if you want to know about mcor dataset, just write mcars and just write this. Okay, no help. mcars. Okay, empty car. Yes. Okay, sorry. There is a mistake. Empty cars. Yeah, there is details. So if you know about the data set, the detail about this data set, empty cars, you can just write question mark empty cars in brackets, and then you will see empty cars data sets and R documentation. This data is built in the R and motor train car road test. So you can see about the detail that which type of data this is. You can see the name of the variables. These are the name of the variables: mpg mile per gallon. So this is the mileage, and cycle number of cylinders, displacement, and HP gross horsepower. So this is the horsepower, and D rate, rear axle ratio. WT is weight of the core. So these are the variables. So if you are interested, you can see the names and with the units as well. So this is a detail about the data. This data. If you have another data, you can of course do the same thing and you will see the detail of the data. So this is quite easy, no problem. You can see the detail of the data because this is extremely important. When you are analyzing data, you should know the variables, because when you know the variable, then you know that the behavior of the variable as well. So let's attach this data by using this command, data empty cars. It's fine. It is not. It have done now. You want to see the first columns, first values of the data, not column, first values of the data rows. So just look at this, and this is the data. These are the types, and these are the variables which is explained here. So you know the variables. We will take these three variable: mpg, mileage, mile per gallon, mileage, horsepower, and weight. And then we'll explain the correlation analysis, that how we can do the correlation analysis and what is mean by that correlation analysis. That is more important than interpretation. We have done in the previous two videos, which I have done with the Python. In that case, we have performed the correlation analysis both linear and non-linear using the data from that was also from online, but that was from some website CSV file, and this is directly connected from here, because you can retrieve the data from CSV file which is available online, but this data is built in with the R, so you don't need any website and something like that. It's quite simple. Okay, now select some variable, like selecting the MPG, HP, and WT, which is explained here. So you can see, just selected data, then empty cars, and you are choosing, these are the columns you are choosing, by the way. Remember, before this comma, this show number up, show the rows. So when you are writing something here, this means that you are selecting the rows. But if you are writing after comma, because we have 3, so we are writing C. If we are selecting 1, we don't need to write C and brackets, we just write the name. So we are just subtitle C and then the 3 variables, and of course with the commas, double commas. So we are selecting these 3 variables from this data set. So we will have the data in the selected data. It will be stored in selected data, and there will be 3 variables. Just have a look. Okay, and now just write HEAD and selected. Yeah, it is already here. So selected data. Yeah, that's quite easy. So you now have only 3 variables, 3 columns, 3 variables, MPG, HP, and WT. There are 3 variables. So you need to learn these things as well, by the way, because the objective is correlation analysis, but on the way you need to learn these things as well, how to subset, how to extract variables from a big data. Now I need to calculate correlation matrix, and this is core is the function, and then selected data is my data, and you can use this as well. So just write this, the correlation matrix is calculated. Now I need to visualize the correlation matrix. You can print the correlation matrix, or you can write just the correlation matrix. You will see the values, numerical values matrix. So this is the correlation, this is the correlation matrix. This means that this one is the correlation between MPG and NPG. Of course, this is one because the same data, so there is one correlation. We don't need to interpret this because there is no need. This is the correlation of the data with F self, so we don't need about this. This is the correlation between MPG and horsepower. So of course there should be negative correlation. Why? Because mileage or mile per gallon, mileage or miles are kilometer per gallon, so the unit is mile here. So mile per gallon decrease when the horsepower increase. You just need to go back to the basic definition of correlation, which I have explained in my first video, which I have done with the Python. So when you increasing horsepower, mileage per gallon decrease, and when you decrease horsepower, mileage per gallon increase. So there is inverse relationship. So this means that there should be negative correlation. Similarly with the weight, when you are increasing the weight, mileage per gallon decrease. So the negative relationship is there between these 2 variables with the mileage per gallon. And similarly, you can interpret all these values, because this is the correlation between these two. Then this is the correlation between mileage per gallon and HP, and this is the correlation between weight and mileage per gallon. And this is the correlation between HP and mileage per gallon, HP and mileage per gallon, and so on. And so you can interpret the result in that way. Okay, you can interpret it in the similar way as I have done the first row. Okay, now if you want to plot this correlation matrix, you need this library, core plot, loaded, and then plot. You can plot the correlation. Yeah, so that's nice. It's nice plot the correlation. And the side, this is the bar. You can say the legend show the. You can say this show the correlation from -1 to 1, and these are the variable MPG, HP, and WT, and this is MPG, HP and WT. So this is the correlation between MPG and MPG, which is of course 1. And this is the correlation between MPG and HP. This is the same thing, the same matrix, but this is visual and the other was numerical. And this is the correlation between MPG and WT. So you can see this correlation is little, in some ways, it is weaker. This is negative correlation, but weaker somewhere here. And this is stronger. I mean, this is toward -1 in this direction. So you can interpret the same way as we have done about the matrix, because it's the same like this. You know, this correlation is between MPG and HP is 0.77. It's lie here, somewhere here. And this, the other correlation, this between MPG and WT is stronger, that is 0.867, so it's stronger. So you can explain, you can print like this for your paper, your report, your thesis, or you can present this matrix as well, whatever you like. There are some other visuals you can visualize in different way. In the square, I have done already like this. So you can do now ellipse, the same meaning but with different symbols. So maybe you like this. It's look nice, yeah. So you can do like this, the same interpretation, the same legend, the same variables. Or you can say the number is also you can express in a number. So this matrix is okay, but if you think this look like better, so you can do like this as well. It's the same thing like this matrix. Just look at the correlations, but it's in a different style, like the values on different color and then the legend bar. So if you like this, please go ahead. And now shade. Look at this, how it look like. Oh, this is something. You the same thing. I already said the same thing with different styles and colors. And now color. So this is the same thing. There is no shade. And then pi, this is a different style. So you will see, you will like this as well. So this is also, this is more higher, lower correlation than this. Since your list spot is without correlation, this means that strong correlation as well from the color as well as from this. So you can like this as well if you like. And the last thing in the visualization, that's something different. I want to show this. This is the adding labels and titles. So this is the full, you will see full. Yeah, this is something like this. This is also nice. You can present like this. The interpretation is similar, by the way. There is no difference. So similar interpretation you can do. And the last thing in this lecture, I would like to do the testing of the correlation, between the two variables, whether the correlation is significant or not significant. So you can do like this. Significant testing, core test, the result will be stored in core_test, and the function is core.test. Remember one thing more again, if you want to know details about any function, just write !cor.teest. This means that what you need to do, you need to write function name and then brackets, and then click, and you will see here. So this is the detail about this. You can use the whole command, but you can use the simple command. Just mention only the two data set between which you want to test the correlation, whether it is significant or not. So this function will test the significance and store the result here in core_test, and then you can print. Okay, it's work, and now print it. So this is the correlation. The t-test is -6.74, and I think it is very high. I mean lower on the other side, in the lower tail. Degree of freedom 30, and p-value is 1.788 e raised to power -07. So very low. So this means that this is significant. So you can get inference from the t statistic, but of course the p-value is quite obvious. This is correlation is significant at 5% level of significance. The alternative hypothesis to correlation is not equal to 0. Okay, this also mentioned that the correlation is 0. This means the null hypothesis state the correlation is 0, and that the alternative hypothesis say that true correlation is not equal to 0. So of course the correlation is quite high. You see, this is the correlation. It's quite high. So of course we have a higher t value and we have a very low p value. So this means the correlation. This is the sample correlation, but the true correlation is not equal to 0. And this is the some 95% confidence intervals. So we have a lot of information here. We have a t-statistic, degree of freedom, p-value, and the correlation value, and the 95% confidence interval as well for the correlation coefficient, for the estimate of the correlation coefficient. So this is all about linear correlation analysis. Or in the next video, we will do rank correlation analysis or non-linear correlation analysis in R and RStudio, for which we will use Spearman-Rowe correlation analysis and Kendall-Tau correlation analysis. So I will summarize what we have learned in today's video. We have learned about we have learned about how to attach online data, built-in data in R and RStudio, and then how we can extract variables, dependent variables from that data, and then how we can calculate the correlation between those variables, and then how we can display in different style those their correlation matrix. And at the end, we have done testing the significance of the correlation coefficient. I hope you like the content, and I think it's enough for today. So thank you very much, and see you in the next video. Ciao.